So let's start this lecture. So in the last few classes, we have discussed about writing chemical formula. We discussed about how to write them, and how to write, what's the rule following them, what's the rule for writing us, ik, and all these things. Then we discussed about the basic concepts like what matter is, what's matter made up of, and what is an element, what's a compound, what's a molecule. I've given a thorough example of all these things. And now we need to do the next topic, which is law of chemical combination. Once this is done, we'll jump in directly into mole concept. So let's begin with this law of chemical combination. Now, why are we studying this law? It's a question that you may have in your mind, right? So the reason we study these laws is because these laws are the ones which helps to understand that how compound actually forms. Like if CO2 is there, how is it forming? You know, what are the rules behind it? Is it random or there is a specific logic? Meaning, is the amount of carbon and oxygen fixed while it forms CO2? What is the entire history behind how the chemical compound would have formed? So we'll be talking about those things, and we'll see some other laws as well. So with that, let's start. So let's start with the law of chemical combination. So basically, these are the laws that we'll be studying. So we have first law, which is law of conservation of mass, which is very commonly, you might have studied this in class 9th also. Then we have law of definite proportion. This is also there in 9th. And the next one is law of multiple proportion. Then it is Gay-Lussac's law of gaseous volume, very, very important for questions involving gases. And the last one is, yes, Avogadro's law. So once these laws gets over, we can jump directly into mole concept. So the laws are law of conservation of mass, law of definite proportion, law of multiple proportion, and Gay-Lussac's law along with Avogadro's law. So let us start with the first law, law of conservation of mass. Conservation basically means the mass cannot be destroyed or created. That's what it means, right? So let's begin. See, the statement of this was proposed by the scientist Antoine Lavoisier, as you can see, and he said that matter can neither be created nor destroyed, meaning we cannot create matter. Like for example, this charging thing I have, right? If I cannot destroy this, right, I can just transform it into something else. I don't like this band kind of structure, I can make it as a rod. I can transform, but I cannot destroy or create matter. That's what he said. Now, like for example, when we take carbon and oxygen, we are not destroying them, but we are transforming them into CO2. Now, what does this law say? This law also says there's another statement of this law that we must remember. This is the law that is very generic, but there is a law based on this particular based on chemistry. So alternative statement of this law is in a balanced chemical equation, in a balanced chemical equation, mass of reactants is equal to mass of product, is equal to mass of product. So you must remember this also. This is the better statement if you ask me. So this is another statement, but you can also remember the other one, that in a balanced chemical equation, mass of reactant is always equal to the mass of product, right? So let's see the next theory. We'll now try to validate this. I mean, when I'm saying mass of reactant is equal to mass of product, is it really the case? Let us see. Like for example, when CO2 forms, what are the elements we need? So we need carbon and we need oxygen. So see, we need carbon along with oxygen. And that's how they combine to give you carbon dioxide. Now, the elements required are carbon and oxygen. See, we need carbon and oxygen. And the carbon molecules reacting with O2 to form CO2. Now let's try to see their masses. What's the atomic weight of carbon? From junior classes, you know that mass of carbon is 12. However, I will be discussing this in the next class, next lecture, or how we find the masses and all. But for now, let's assume that the mass of carbon is 12 grams. Mass of one oxygen atom is 16 grams. So mass of two oxygen atom will be 32, right? It will be 32. Now add them up. It gives you 44. Now, 32 plus 12 is 34. We'll try to see, is really the mass of CO2 44? If it is the case, then the law of conservation of mass is indeed a real thing. It exists and it is true. So let's have a look. See, C plus O2 is 42. So it is coming as 44, right? So the answer is 44 grams on the left, 44 grams on the right. Is it obeying law of conservation of mass? Yes. So law of conservation of mass says that mass cannot be destroyed or created. It is just transformed. C plus O2 has become CO2. But the mass on the left is equal to the mass on right. That's what the law says. Okay. Now, let's look at this question. So I want you guys to first try this one before we solve it. So I want all of you to please pause the video and attempt this question. Please pause it. Okay, so I hope you have done it. Now let us see how we can do this. So first thing first, we must know how to write the equation. So let's write the equation. So they're saying the CaCO3 is of heating. We are heating it, right? So if you want to solve it, it should be, see, CaCO3 is heated. What do we get? CaO plus CO2. Now they're saying 10 grams of CaCO3 is being heated to give you 4.4 grams of CO and the CaO and 5.6 grams of CO2, right? So quicklime is got, and what is the amount of quicklime we got? We are hitting limestone, we got 4.4 grams of quicklime and 5.6 grams of CO2. Is it obeying the law of conservation of mass? Yes, it is obeying the law of conservation of mass. How? Because the mass of reactant, see, the mass of reactant is 10 grams. And what's the mass of product? So if you see, mass of product is actually, mass of product is coming as 4.4 grams plus 5.6 grams, right? Which gives you 10 grams. So yes, it obeys law of conservation of mass. That means it's true. That's how, it has been solved as well. This is how we can attempt it and do it. So this is how, the book has, this is how we can solve it. Same method. So yes, follows law of conservation of mass. The next law that we have to study is law of definite proportion. As the name says, definite means what? Fixed, right? I mean, it's a fixed thing that will happen. So that's the definite, meaning of the word definite. It's fixed basically. And let's have a look. Now, water. Water is present. We have water in ocean also. We have water in sea also. We have water in river also, and we have water in drinking water bottles also. They are all waters. But do they have different formula? Think the water that we have in the ocean, is it same as the water we have in our bottle? Yes. The water is same. Means the source H2 is same. It's not that the salt part is there. I'm just talking about the water. It's the same water. It's just that the ocean water has lots of salt mixed in it, but the water that we have has a very little amount of it present. So this law says that no matter what is coming from lake or from oceans or in the laboratory, water is fixed. Water is water. It has a ratio of 2 hydrogen atoms and 1 oxygen atom. Mass wise, 2 gram mixing with C. And this also case. Volume wise it's fixed. Mass wise it's fixed. 11.1% is hydrogen, 88.89 is oxygen. It's fixed. And this is what we mean by law of definite proportion, meaning irrespective of what is the source of a substance, any compound always contains same elements in a different proportion of weight. Like for example, water molecule has 2 grams of hydrogen because that's the mass of one hydrogen atom is 1 gram. So 2 hydrogen atom is 2 gram, and mass of oxygen is 16 grams. So the ratio is fixed, 1:8. So whenever hydrogen combines with oxygen in this ratio, it will form water, no matter from where you are getting that. This is what it means, irrespective of source. I mean, doesn't matter from where it is coming, it's fixed. That is what the law says, right? So it was given by Joseph Prost, as you can see, and he said that a given compound always contains same elements by fixed ratio. Like for example, you see, you can take a case here. Pure water has a ratio 1:8. Same thing I told you sometimes back. Next. So look at this question here. They're asking if this much, don't get scared by looking at the size of the question. It's a very easy one, just read it. 1.375 grams of cupric oxide was reduced by heating in a current of hydrogen, and weight of copper was determined as this much. In another experiment, this amount of copper was dissolved in nitric acid, and we got copper nitrate converted to cupric by ignition. The amount of cupric oxide was 1.476. So show that the result illustrate law of constant composition or definite composition. So basically, we are getting cupric oxide. We are getting, see, there are different sources of getting copper. In first experiment, what was the weight of cupric oxide? 1.375. What was the weight of copper? It was 1.098. Right now, see, what's the weight of oxygen present? That would be the weight of copper oxide minus weight of copper, right? So the amount of oxygen present is 0.277 grams. So how much amount of copper oxide is there? How much percent of oxygen is present in the copper oxide? This divided by this into 100. You don't really have to solve it, just understand an example. So we have around 20.1% of oxygen present in CuO fixed. Now we'll see whether the same amount is present in Cu of oxygen in the second experiment or not. So in second experiment, what amount of copper was taken? Have a look. See what amount of copper was taken in the first in second experiment. See, 1.179 grams of copper was taken, right? And what amount of cupric oxide was formed? This much. So see, there are different ways of forming copper oxide and copper. So here, see, copper oxide was this much. What is the amount of oxygen present? It is 0.297. Find the percent. It will come exactly same. See, so since percent of oxygen is present in both the cases, percent of oxygen is same, we can say that it obeys law of definite proportion. See, or law of constant proportion or composition. That's how we can understand the law. The last law that we have to study now is law of multiple proportion. So in this law, basically we will be studying about the possibility of different compound formation. What I mean by that is, if carbon combines with oxygen, will it just give CO2? Can't it give something else? Yes, it can. And this law talks about the possibility of formation of multiple compounds from two same elements combining. Like sulfur can combine with oxygen to give you SO2 also. Sulfur can combine with oxygen to give you SO3 also. It's going to be, type of reaction. It is type of law which will tell you about the different possible compound formation from two same set of atoms. Let's see. So this law says that if two element combines, please listen to look at this law. If two element combines to form two or more compounds, like for example, C combines with O2 to give you CO2, right? And C also combines with O2 to give you CO. See? Then the masses of one element that combines with fixed mass of other element are in small whole number ratio. Meaning, see, carbon can combine with oxygen to give you CO2 also. Carbon combine with half O2 to give CO also. So they are saying, if you react 12 grams of carbon with 32 grams of oxygen, because mass of oxygen is 16, right? So two of them will have a mass of 32 grams. When 12 grams of carbon reacts with 32 grams of oxygen, and the same amount of carbon reacts with 16 grams of oxygen, we get two different products. CO2, we get CO. See? And they're saying that the element which is making two different kind of compound by reacting with fixed mass of one, they are in the ratio of a whole number. Meaning O2 from CO2 and O2 from CO, they have a fixed whole number ratio, 2:1. That's what it says. That means they talk about different possible compound formation. So see, let's read it once again. If two element combines to form two or more than two compounds, then the masses of one of the element that combines with fixed mass of other element. What is the fixed mass here? Carbon. Are in ratio of small whole numbers. What is the whole number ratio? 2:1. This is what the law says. So I hope this law is clear. Let's see some demonstrations of this law. Now see, hydrogen reacts with oxygen. It can give you two things. If I keep the mass of hydrogen fixed, then oxygen can change twice, and give you two different compounds. Let's have a look. It can give you H2O and it can give you H2O2. So see, mass of hydrogen is 2 grams in both the cases. So it's the fixed mass. But if it reacts with 16, it gives you water. And if it reacts with 32, it gives you hydrogen peroxide. So yes, so they do have a ratio of 1:2. That is what the law says. So we can see that there's an example given. Hydrogen and oxygen are combining to form two products. The hydrogen content in one of these is this much, while the other is in the other one it is 11.2. So that they illustrate multiple proportion. How do we do it? So they're saying hydrogen and oxygen are known to form two compounds. Hydrogen content in one of these is 5.93. In other one it is 11.2. Then what will be the how we can demonstrate law of multiple proportion? Let's have a look. See, hydrogen is 5.93%. So what amount will be oxygen? Of course, it will be 94.07, right? Then in the next sample, what is the amount of hydrogen? 11.2. What will be the mass of amount of carbon in it? 100 minus this, right? Now, in the first compound, what amount of oxygen was combining with the hydrogen basically? See, if you compare that, so that ratio would be 15.86. See, for this much amount of oxygen, this much amount of hydrogen was combining. Let's do the same thing with the other experiment also. For 8.88, how much was combining? 11.2, the ratio is 7.9. Now, 7.9 and 11.15.86, are they in the ratio? Yes, they are in the ratio of 2:1. So yes, it obeys law of multiple proportion. And that's how we can understand this law. So I hope this idea was clear to you and you have understood how this is done. So that's it for now. In the next slide, in the next lecture, we'll talk about the other two laws, which is law of Avogadro's law and law of Galaxies. So we'll talk about them in the next session. So I hope this session was, you enjoyed the session and it was helpful. Thank you so much.